If you are in Chemistry 30 or any Intro to Organic course, here is a test put on from Quest A Plus with all old diploma questions that you can try. You should definitely look at this and make sure you know all of what's in here before your test. So the first type of question that you usually will be asked is to be able to identify things that are organic. So you want to remember that dioxides are not organic. Anything with a metal or the a cyanide ion is not organic. And the last one is the carboxide ion is also not carboxide, sorry. That's carbonate ion is not organic. So the rest would be, so number 2 works, number 4 works, number 7, and number 8. This next question is similar. We have all of these compounds that are in the air, and that's just asking out of these which ones are organic. So this first one would not be because of that CN. This one is not because it's a dioxide. This one works. This one works. This doesn't have carbon in it, so it's not organic. This one definitely works. Carbon dioxide is not. And number 8. So this would be 3, 4, 6, 8. So those are the first kind of easier ones, just knowing what's organic or inorganic. This next one is asking which one of these could be a formula with C8H16, and then which ones are correctly named. So going through this, because this is benzene, we know if it's a benzene ring, you have alternating double bonds. So with that, you definitely do have 8 carbons if we did add all of them up, because we have a carbon here, 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 and here. And then you want to be able to add your hydrogens. So from the chain, you have 5. Then looking at your lines, you would have 1 hydrogen on each of these carbons. So this is actually C8H10, so this is not going to be an option. Looking at the next one, again, same thing with the chain, and counting around, we still have 8 carbons, but now without that ring inside, we have 2 carbons on, or not 2 carbons, 2 hydrogens on each of these carbons and 1 here. So when we do add them all up, that is C8H16. And then if we just check the naming, it is ethyl, because this part here is an ethyl group. Cyclo, because they're all connected. And within that cyclic ring, it's 6 carbons, which is hexane. So this looks like my answer. And if we did go through and double check the rest, B is the one that will work out. Looking at our next one, wanting to name this molecule correctly, remembering if you have a hydroxyl group, you definitely have that as your priority. So I'm going to start numbering my carbons from the right. And when I get to number 5, it doesn't matter if I go up or down because I'll have the same name. So I would say on carbon 5, I have a methyl group. So I see that here. And then 6 in my main chain is hexane. And then on carbon 2 and 3, I have 2 alcohol groups, so diol. So the answer there was B. I like this picture because it's nice, a little bit more to date than what we usually see. And just going through it, the first one's asking which one would be an unbranched alkane. If you're not branched, it means you have no side groups coming off. So there are a few options here. Like number 1 isn't a branch. And number 2, there's no branches. Number 3 looks like there's no branches. So there's a few you can pick here. So this is an old diploma question and there would be multiple answers accepted. So I'm just going to say number 2 for this one because I think that one stands out the most. Which one is cyclic? Well, we need to see a ring. So number 1. Halogenated, you are looking for a halogen and only number 3 has a halogen. And an alcohol, you need that OH group. So we know that that's O because it's red and then hydrogen's attached. So number 5. Moving on from here, this one is showing that you know the bromine test. So if you have a sample and you have this isomer and you put that sample of bromine solution and mix it with that isomer, and it's telling you that the solution goes from orange to brown orange to colorless. That means you have an addition reaction where the molecule essentially absorbs what you have. So with what we're looking for, if it is an addition reaction, then we had to break a double bond. Now, going through this, when it's asking about what we have, if it's addition, because we need a double bond, it cannot be saturated. It has to be either C or D. And then if it's going from colorless, or sorry, to brown to colorless. The only one that shows that addition would be C. If it stayed brown, then you would be looking for an alkane. Next one here, looking over this structure, giving some information, and then asks to be able to describe what's happening within. And when we take a look at it, what we do have, we don't have a methyl group. This is a carboxyl group, so we do have that. An ester link, because this is a carboxyl group, it's not an ester at the end. If we would have to have a longer chain, so not that. And it does have a halogen, that fluorine on the end. So the ones that work out here are number 2 and number 4, and that makes our answer C. Now we have this diagram and asking us to classify it. So just going over the options. As soon as you see a benzene ring, you are aromatic. And then looking on our side groups here, we do have a alcohol, so we do have a hydroxyl group. And then this group here, we have carbon, double bond to an oxygen, single bond to an oxygen, and instead of a hydrogen here, you have another carbon, which means this is an ester link. So this one is going to be B. Coming down to the next one, talking about isomers once more. So if you're an isomer, you have the exact same number of what we have within. So we're just seeing what will line up. So going through this one, I'm just going to count my carbons. So I have 6 altogether, right? 1, 2, 3, 4, 5, 6. And then counting your hydrogens. So with here on our chain, we have 3. At this top carbon on my ring, I have 1, and all the rest have 2. So adding that together, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one works. It's definitely that structure. So let's see if it's named correctly. So you have a methyl group and it's cyclic, so cyclo, and then 5 carbons, that is pentane. So it looks like it's A, and you can double check the rest, and we will see that the answer here was A. Okay, so this now, moving on, is talking about fractional distillation. So this is one thing that hopefully you will remember. As long as you know what it is, these questions are pretty easy. Fractional distillation puts crude oil into a distiller, and the lower boiling points will boil first and come out, and then as the boiling points increase and your molecules get bigger, then they'll end up coming from the bottom. So it separates your hydrocarbons. So looking at this, we have a mixture. So we have a hydrocarbon a little bit smaller and one a little bit bigger, and it's telling that it's heated in the tower to separate them. And then if it is heated, the hydrocarbon that will condense at a lower collection point has to be the bigger one. And it's because its boiling point is higher. So the one that would match that is B, the bigger one with a higher boiling point. This next piece here, we have a piece of wax, and it's asked how it's classified. So we see that alternating double bond, it's going to be aromatic. And then looking at this compound in water, it's not going to have that much solubility because there is no dipole going on. We don't have a polar molecule, so it will have low solubility. So the answer is D. Looking at our next part, getting into some reactions. So if you have an addition reaction, you are breaking a double bond. And if you are breaking a double bond, then you have an alkane, adding a simple molecule, and then you'll end up with just one molecule. So the first one looks like it's going to be addition. Substitution, you still have 2 reactants, but you also have 2 products, and we're just swapping something. So it looks like that will be number 3, because it looks like your bromine and a hydrogen are going to swap places, making 2 new molecules. Elimination, you start with 1 molecule and something gets eliminated off, usually water or some smaller molecule, so that will be number 2. And esterification, I find that's the easier one to recognize because you see a carboxylic acid with an alcohol making an ester and water. So it usually looks like one of your more complicated reactions, but it's, I think, pretty easy to identify. Looking at this next one, so we're using that information with the 4 equations to answer the next 2 questions. So the first one is, what of the following rows identify the equation that contains the organic reactant with the lowest boiling point, and then the organic product with the highest boiling point. So going through this, this first reactant wouldn't have a high boiling point because it's not polar. The second one would. Looking at the next one, because it's asking about the organic reactant, it's still looking at that C2H6, which is like number 1, so same idea. And then the reactants in number 4, those are both polar, so they both would have a high boiling point. So far we're looking at either number 1 or 3, and we can take those two out. Now, if we're looking at the product with a higher boiling point, we need to see something that will make that molecule polar. This first one's not going to be polar, not polar. This has a tiny dipole, but this last one's probably our best choice because we have that carboxyl group and some lone pairs on those oxygens. So it looks like for this, D is the best one to choose. The next one is just, once again, being able to identify a reaction. If you're elimination, you're starting with one reactant and taking something off of that reactant to make 2 products. And the one that shows that would be number 1 and number 2. Number 3 shows substitution, and number 4 is esterification. So this would be A. All right, so this one shows we have 2 methods to make the same product. And then it's asking us how to make that product. So in number 1, if we take a look at it, we do have 2 reactants and 2 products. And it looks like in this one that we do have some substitution going on. So we need to see what we started with to substitute an OH group on. And I think the best choice also, we have an iodine introduced. And the only one that has an iodine is number 4. And then again, we just mentioned this is a substitution reaction. In the second one, we have 2 reactants and only 1 product. So this looks like this reactant came on to the first reactant, meaning a double bond was broken. And the one that shows that is number 2, and that is called an addition reaction, so 5. So that was 4, 6, 2, 5. Next, we're talking about when methanol and ethanoic acid react. So if you have an alcohol reacting with a carboxylic acid, you are going to get an ester. And when you are naming your ester, you always name the alcohol part first. So this is going to be methyl ethanoate. And then it does tell you the product. So, sorry, I should have kept reading. So it's methyl ethanoate, but it's not only, because for these 2 to form, water does get released because it's part of a condensation reaction. So it's methyl ethanoate, but it also does release water. So D is also one of the products. Number 12, this one, the type of reaction that occurs when ethene, so we have a double bond, is reacted with chlorine. So we have a double bond, we're going to break it. That's an addition reaction, an addition reaction. And the name of that compound that is produced, if we're adding chlorine gas, that would be Cl2. So we'll have 2 chlorine to place. And breaking that double bond means we're definitely not going to have a double bond anymore. The answer here will be A. This one, taking a look at it, asking which one would be a structural isomer. We just want to figure out how much of everything we have. So I'm starting with the carbons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're looking for a molecule with 9 carbons, 2 oxygens, and a certain number of hydrogens, which we can count after if we can't narrow it down. So just starting with that, if you have an ethyl group and octanoate, that means you have 2 carbons from ethyl and 8 from the octanoate, which is a total of 10. So this one's too many. Methyl heptanoate, methyl would be 1 carbon, and heptanoate would be 7. That would be a total of 8. So we can keep going. Methyl octanoate, methyl would be 1, plus octanoate would be 8. That gives us 9. So far this is the only one that satisfies with carbon. And we can double check this last one. Propyl would be 3. Heptanoic would be 7, and that would be 10. So even without checking the rest, which we should, but process of elimination would show us that the one that satisfies the carbon is 9. If it's a carboxylic acid, we definitely have the double bond oxygen, single bond oxygen. So we'd also have 2 oxygens. And then we can double check, draw it out, and we should see that our hydrogens are the same. And so yeah, C is our answer. A second part of this is asking which reactant would be necessary to produce this ester. So we know that the 2 things that come together are carboxylic acid and an alcohol. The chain that's connected to the oxygen that's by itself, not the one with the double bond, that one comes from the alcohol. So that has 1, 2, 3, 4, 5 carbons. So if we look at our answers here, we want a chain with 5 carbons. So it looks like A could work, B could work, but C and D are too small. And then the part that is connected to the double bond oxygen, 1, 2, 3, 4, that comes from the carboxylic acid. So we need to see a chain of 4 on that acid, and it looks like the only one that would work here is A. Now the last part that you probably were taking a look at in organic chemistry is polymers. So there's 2 ways to make a polymer. One is the series of addition reactions, and you break that double bond, but the other way is a series of condensation reactions. So if you see anything that resembles an ester link, it's probably a condensation reaction. So over here, that double bond that we're seeing is showing could be that ester link. You can also have an amide link, and it's very similar, except you have a nitrogen instead of an oxygen. So here, the monomer that can make up this polymer contains A. So I probably would not go with the first bit because it doesn't look like an addition reaction. And if we keep going, the structure of the polymer closely resembles the polymer found in. And then I would say this looks more like an ester than just a chain. So I think C is the best answer, but I definitely thought about this one for a while and drew out a few pictures just to double check. And I think C fits it the best, and C was the answer. And then this next one, I copied it twice. It was the same thing. Then this next one was the polymer. And in this one, because you don't see any double bond with oxygen or nitrogen, this is just going to be an addition reaction. So the monomer that could be used, we need something with a double bond. So it cannot be A or B. It's most likely not D. And again, we could draw this out and show that we're breaking that double bond, but C is the one that's going to fit. I hope you found this helpful. Again, this came from Quest A+. It's a great website. Check it out. I also really encourage you to check out my website. You would find linked lessons to YouTube, linked videos, and practice tests. If you did find this helpful, please subscribe. And as always, thank you so much for watching.